In this video, we are going to very quickly go through the Pythagorean theorem and how to find distance or length on a grid. We're going to begin with the Pythagorean theorem. If at any time you feel like the video is going too quickly, please pause it, put it on a slower speed, or rewind it and watch it again. This video is very important, and I'm going to try and do it as quickly as possible, but I'm going to try to convey as much meaning as possible. Watch it as many times as you need to. Okay, you've heard of the Pythagorean theorem before. The Pythagorean theorem says that c squared equals a squared plus b squared. And you might say, well, what are a, b, and c? Well, the Pythagorean theorem only applies to right triangles. So it doesn't apply to this triangle, but it actually applies to this triangle now that it is in fact right. Okay, well, what are a, b, and c? C is the hypotenuse. You must identify that first. It's so important, that's why we wrote it first. You must identify the correct hypotenuse to successfully use the Pythagorean theorem to find a missing side. So the hypotenuse is opposite the right angle, and then A and B, these are known as the legs. It doesn't matter which one you call A and which one you call B. Notice how the legs are at least in this picture, kind of vertical and horizontal, and the hypotenuse is sort of on a diagonal. The most important thing, though, it won't always be just like that. The most important thing is for you to recognize that the hypotenuse is opposite the right angle. That must stand alone on its own side of this equation. And also keep in mind, A, B, and C are lengths or distances. They are line segments, and they have a length. Again, just to reiterate, finding the hypotenuse, I'm going to draw a bunch of right triangles, and we're going to identify the hypotenuse on each of them and set up the Pythagorean theorem. In each of these examples or diagrams right here, we are going to successfully identify the hypotenuse. It's opposite the right angle, opposite the right angle, opposite the right angle, and opposite the right angle. Again, the Pythagorean theorem only works for right triangles. So let's actually set up the Pythagorean theorem now that we've identified the hypotenuse in each situation. Notice how I'm putting the hypotenuse on its own side of the equal sign. You must isolate and identify the hypotenuse and square it. And the Pythagorean theorem says that the hypotenuse squared equals to the sum of each of the legs squared. So now I'm going to write in each of the legs being squared on the other side of the equal sign. Notice how x is not always on its own side of the equal sign. The thing that's on its own side of the equal sign is the hypotenuse that we identified. So here's the correct setup for each of these examples. And again, it doesn't matter if the 4 and the x are switched. We could have written 5 squared equals x squared plus 4 squared. What does matter is that the hypotenuse is on its own side of the equal sign. You must identify the hypotenuse correctly to successfully apply the Pythagorean theorem to find a missing side length. Here, I'm going to go through the entire process of finding a missing side using algebra by applying the Pythagorean theorem. I'm only going to do this once, so feel free to watch this video often. First, we notice that we have a right triangle. We're trying to find a missing side. We're trying to figure out what x is. We look at the right angle. Opposite the right angle is the hypotenuse. That length or distance stands alone on its own side of the equal sign. Then we identify each of the legs, square each of them. This is the appropriate setup to use the Pythagorean theorem. From here, we're going to follow the rules of PEMDAS, which means square first, don't add first. So the square of x equals 100. Notice how I'm showing every single step. You can clearly see the flow, the algebraic flow of logical thought here. Your work should look just like this every single time. Now, we have x squared equals 100. So keep in mind, this length is not equal to 100. The square of this length is 100. What's the opposite of squaring? It's square rooting. So now I'm going to apply the square root to both sides. And honestly, on the left-hand side, what happens is the square and the square root cancel each other out. So you just have x. On the right-hand side, since this is an equation, we need a plus or minus. Anytime you apply the square root to both sides, of an equal sign, you need that square root. Students tend to forget that. And the square root of 100 is 10. Our answers are x could be 10 or x could be negative 10. However, we know that this is a length or distance that we're trying to find, so it is not possible for it to be negative. No distance can ever be negative. Therefore, x is 10. What are our units? Our units are inches. We have successfully applied the Pythagorean theorem. Every single problem that you do will behave this same way. Now, just as we did in the last problem, you're going to try to find the missing side and solve for x on each of these two problems here. First, you're going to identify the hypotenuse, and then the algebra will happen in just the way it did in the previous slide. Please pause the video because the next slide is going to be the answers to this. Here are the answers to each of the missing sides on the previous slide. Hopefully you paused it. Now, just to be clear, we're going to learn how to estimate this value. This value is a little bit less than the square root of 36, and we know the square root of 36 is 6, because 6 times 6 is 36. So this answer is probably really close to 6. We would guess 5.9. That's how you would estimate this square root. We'll also learn how to simplify this square root. Actually, this one doesn't really simplify, but we'll also learn how to simplify square roots soon. But so this is a decent estimate. You must understand the difference between those two verbs that says estimate. This square root, the square root of 34, is very, very close to 5.9. Why? Because we know the square root of 36 perfectly equals 6. So this 34 is very close to 36, so the square root of 34 is very close to the square root of 36, meaning it's very close to the number 6. More on that later. Here, if you're asked to find a length or a distance on a grid, perhaps you're asked to find out how big AB is. If on the grid it's a vertical distance, meaning just straight up and down, you can just count. 1, 2, 3, 4. AB is 4 big. Oh, and let's see how big is CD. If the distance goes vertically or perfectly horizontally, either one of those two situations, you can just count it out. 1, 2, 3, 4, 5, 6, 7, 8. CD is 8 big. So finding distance length on a grid, if it's vertical or horizontal, you can just count. However, what if I asked you to find this distance EF? EF is slanted. It's kind of on a diagonal here. Now, we can't just count this. We're not going to be precise enough. We're not going to be able to do it successfully. It's probably not a whole number answer, and even if it was a whole number answer, it'd be really hard to figure out. So if you have a line segment that's vertical or horizontal on a grid, you may just count it out. But if it's on a slant, we're going to actually apply the Pythagorean theorem. So on the next slide, we're going to go through these two steps. We're going to make a right triangle, and we're going to use the Pythagorean theorem to find out how big something like EF is. So now, as a continuation of the previous slide, we can count vertical and horizontal distances, but we can't count distances on a diagonal. We're going to have to use the Pythagorean theorem to calculate the distance between points E and F. So I'm kind of continuing the former problem to help you understand. So point E is at -2, -5, by the way. That's a negative sign. And F is at 1, 1. We want to figure out the distance or the length of EF. Well, there are some horizontal and vertical distances that we can use here so that we can apply the Pythagorean theorem. What do I mean? I mean that we can turn this into a right triangle if we push over horizontally and down vertically. Ta-da! We made a right triangle right on the grid. So now we can just apply the Pythagorean theorem. So this skill of taking a diagonal line and using the grid to perfectly tuck it in to a corner of the grid so that you can make a right triangle is a very, very important skill. And then you can just count a little bit. How big is the horizontal change in distance? Well, that's 3. Just count it out, just like we counted earlier. Let's count the vertical. 1, 2, 3, 4, 5, 6. Oh, it's 6 tall. Okay, terrific. So now, how big is EF? Well, let me make that a little bit darker. Well, we can call that X. That's our unknown side here that we're trying to find. And just like usual, we could even bring this off the grid because it's a little busy in there. We now have a side length of 3, a side length of 6, and our goal to figure out EF, we'll call it X, our unknown. We now know our hypotenuse, and we know that hypotenuse squared equals a leg squared added to the other leg squared. So now we just do the Pythagorean theorem. 3 squared is 3 times 3, which is 9. 6 squared is 6 times 6, which is 36. X squared is equal to 45. Let's go up here with it. So, okay, so x squared is 45. Does that mean that EF is 45 units big? No, no, no. 45 units big would be way too big for the grid. That means that the square of EF, or the distance of EF multiplied by itself, is 45 big. So now we'll undo the square by square rooting. And we do know that there should be 2 answers here, but really there's just going to be 1 because EF is only, it's a distance, so we can only accept the positive answer. So how big is EF? EF is the square root of 45 big. If we were to estimate that, well, I know 7 times 7 is 49, so the square root of 49 is 7. So I know this answer is a little bit less than 7. I'm going to guess that it's about 6.8. That would be a decently good estimate. And we could actually check our answer by multiplying out by hand 6.8 by 6.8, and hopefully it gets really, really close to the number 45. But so we actually figured out, we should really label this, please label this. EF is about, is the square root of 45 big? That's an exact answer, or as an estimate, we could say it's about 6.8 big. The directions would really lead us to what they exactly want us to do here. So we were able to figure out a slanted distance. How? By using the grid, making a right triangle, counting, and doing the Pythagorean theorem. This is the crowning achievement of this video and the most important few minutes. And now, on your own, based on all of the examples that you've seen, the challenge for you is to figure out the length or the distance of MN given that it is a slanted line. What you will do is you will use the Pythagorean theorem, make a right triangle. Well, you'll make a right triangle first, and then you use the Pythagorean theorem to find the distance or the length of MN. Good luck. Make sure that you do this problem completely. You should be able to do it. If not, you need to go back a slide and watch the previous example a couple more times so that you understand the process. This entire video has been about using the Pythagorean theorem to find length or distance. And thank you and good night.